Good day, viewers. I welcome you once again to this exciting moment in mathematics. My name is Okolo Christian. Today we'll be looking at solution to polynomial equations. Now, by this topic, naturally, the first thing that comes to mind is what is polynomial equation? A polynomial equation can be written in the general setting in this form. Px is equal to summation an minus j xn minus j going from 0 to n, where our n is elements in the set of natural number. Of course, n is greater or equal to 1. Okay. Now, we can expand this further. If we expand this further, we'll have an s raised to the power n plus an minus 1 s raised to the power n minus 1 plus an x raised to the power n minus 2 plus and so forth till you get to a naught. Now the x here is the independent variable, where the an minus j's are the coefficient of x. Okay. Now observe from what we have here. So far we've written this polynomial equation up to the 5th degree. So the n represents the degree of the polynomial. If n is equal to 1, then we have it that that polynomial is a polynomial of degree 1. If n is equal to 2, it becomes a polynomial of degree 2. If n is equal to 3, it becomes a polynomial of degree 3. If n is equal to 4 and 5 and so on. Now the special name given to them for the case of n equals to 1 is linear equation. For the case n equals to 2 is quadratic equation. For the case n is equal to 3 is cubic equation. For the case n is equal to 4 is quartic. For 5 we have quintic. For 6 we have septic. So we can go on further. However, we decide to stop at a 5th degree polynomial. Now one may ask, why did we stop at the 5th degree polynomial? This is because so far the solution to polynomial equation of degree 1 has been solved, degree 2 has been solved, degree 3 has been solved, degree 4 has also been solved. For degree 5, there is no known general solution to polynomial of degree 5 and beyond. In fact, as a matter of fact, it still remains an open problem in mathematics for the solution of this quintic equation in the general setting. Some mathematician has actually put up a theory that says that the polynomial equation of degree 5 and above cannot be solved in radical. So we decide to limit ourselves to this particular set of polynomial equation. Okay, now we begin with the linear equation. Like I said before, now if n is equals to 1, we have the linear equation which is written as a1x plus a0 equals to 0. Or most of the times, students oftentimes ask, what is the importance of all this equation? Why do we study all this equation? Where can it be applied? Now, first thing should come first. It is important you understand this concept of mathematics. Now, if you have understood this concept of mathematics, you will now appreciate it better when it is being applied to real life situation. Okay? For instance, in physics, if this is an object, if you apply a force F on this object with a mass m, now the natural thing is that this object will accelerate. Well, of course, we know that F, force is equal to mass times acceleration. Okay? Now, you observe that acceleration A is defined as rate of change of velocity with what? Time. Now, looking at this, the V is the final velocity, where u is the initial velocity. If I simplify this further, I will have that v minus u is equals to at. If I make v the subject of the formula, I will have v is equals to u plus what? 80. Now, from what we have here, u is the initial velocity and v is the final velocity. You observe that this final velocity depends on what? T. It's a function of time. So that I can write it as Vt is equals to u plus at. Now, looking at this equation, one might easily ask, what is the velocity, or what is the time when the final velocity is equals to 0? By implication, it means that at what time will the final velocity be equals to 0? Now, if this final velocity is equals to 0, it simply means that Vt is equals to 0. For such a case, we will have u plus at to be equals to 0. This is nothing but a linear equation. Now, if you compare this with this one, star and star, you observe that you can liken this t to x, and you can like the coefficient of t here is a. You can liken it to this a1, where u can be likened to this. Okay, so this is one case of the application of a linear equation. Most of the motion on a straight line is governed by this equation of degree 1. Now we look at the case of equation of degree 2, which is known as quadratic equation. Now, if n is equals to 2, we'll have a2x squared plus a sub 1 x plus 0 equals to 0. Okay. Now, the quadratic equation, we can find its application in engineering, in social science, in management science, also in financial mathematics. Basically, in financial mathematics, when we use it to determine the maximum point of the point where we can have the maximum profit for a profit function. Also, we can use it to find the point where we have the minimum cost for a cost function. And also, it's also applicable in engineering, where we apply it when you construct bridges, and it is also applicable in projection of particle, missile, and bomb, and so on. Now, in particular, if suppose this is a particle, okay, and you give it a initial velocity u, now what happens is that this particle will move, and after a point, after some certain height, it will now descend back. Okay. Now, if you observe, at any point tangential to this trajectory or this curve, this particle have a horizontal component and also a vertical component that makes it to cover both vertical distance, which I represent with y, and also a horizontal distance, which can be represented as x. Now, the vertical component of this initial velocity that makes this particle to cover a vertical distance is given as uy is equals to u sine theta, where the horizontal component ux is equals to u cos theta. Now, if we recall the formula for the distance, uh, covered by a particle as we have it in physics, we have that x is equal to ut minus 1 over 2 gt squared. So now if I'm interested in a horizontal distance, then my uy, of course, which is a function of t, is now equals to u sine theta minus 1 over 2 gt squared. Okay. So now looking at this equation, you observe that if this particle is projected from this point, after some time it will land back to the point where you projected it from, but then covering a distance x. Now, but at this point, if I call here A and call here B, at this point B, you find out that the vertical distance is actually 0. So that one may ask, at what time does it take this particle to land at this point B, or at what point will the vertical distance covered by this particle become 0? So for such a case, we will now have it implies that x y sub t is equal to 0. Now to find the time for this particle to hit back the plane, then we'll be solving for t in this equation, u sine theta t minus 1 over 2 g t squared is equal to 0. This is nothing but a quadratic equation for which we have to solve for the time t. Okay, I hope this will do for quadratic equation. Now, application of these equations aside, now let's look at the mathematics involved for this first and second polynomial. Like we said before, now n equals to 1. We have the linear case x plus a 0 equals to 0. N is equals to 2. We have a 2x squared plus a1x plus a0 equals to 0. Okay. Now, like I told you before now, that the solution for polynomial equation of degree 1 and degree 2 is none. And the first person that gave this solution to this problem is an Islamic scholar who he lives around 800 AD, and his name is Al-Khwarizmi. From here, you can see if I make x the subject of the formula, I will have x is equals to minus a naught over a1. Okay, this is the general formula for any linear equation. Now, for quadratic case, we have x is equals to minus b plus or minus square root of b squared minus 4ac all over what? 2. These are the formulas for case of linear equation and for that of quadratic equation. Okay. Now, we'll take specific example of each of these problems, which is for the number 1, which is quite elementary for the number 1. But however, we'll just do justice to that. If I have 2x plus 4 equals to 0. Now, if I'm asked to solve this, solving for this is nothing but finding the value of x that will satisfy this equation. Okay. Now to solve for this, what I will do, solution, if I 2x plus 4 equals to 0, if I move plus 4 to the other side of the equation, I have 2x is equals to minus 4. So in order to make x the subject of the formula, I divide both sides by 2. If I do that, I'll have x is equals to this, I have x equals to 2. So that if I substitute 2 here and solve, I'll have 0. So x equals to 0, x is equals to 2 is actually the 0 of this solution, or you can call it the root of that solution. Okay, now I think that we should do for the case of linear equation, knowing that it is quite elementary. So now we'll move over to quadratic equation. Now, in quadratic equation, we recall from what we did in our secondary school level, that quadratic equation can be solved by, several methods. Okay, so we look at method of solving quadratic equation. Quadratic equation. Now, one method we have the graphic or the graph method. Simply put, the graph method. The graph method. 2, we have the factorization method. 3, we have the formula method. Okay. Now, from number 1, we're not going to treat number 1 because for you to do that, you need a graph sheet to do that. So we skip number 1. Then for number 2, factorization method. Now, in factorization method, number 2, now, well, permit me to say that aside or apart from the graph method, you have just the factorization method and the formula method. Now, most times we can refer to techniques used in deriving this formula method as a method itself. I don't have problem with that. But for me personally, we have basically 3 methods of solving quadratic equation: the graph method, the factorization method, the formula method. Okay. Now, later, as we go on with this series of presentation in solution to polynomial equation, I will show you why one can comfortably say that we have only 3 methods for solving the polynomial equation. Okay, because sometimes you find that in text they might give you a completing the square method. They can also give you maybe some other method different from completing the square method. But at the end of the day, you observe that those methods will finally give you this formula. You will finally derive this formula. Okay, so now for the factorization method, the techniques we employ in factorization method is what we call the vertex equation. Okay, that is what we employ in factorization method. Okay, now 3, for the formula methods, now in the formula method we can apply as many methods as we can. Okay, we can use the completing the square method, I or A, okay, we can use the completing the square method. We can also use the differentiation method. Also, we can use what we call the depressed or symmetric equation method. Okay, we can also use the matrix method. To be specific, we call it the circulant matrix method. Okay, also we can also use what we call E. We can also use what we call the undetermined parameter methods. Now, I know that we are familiar with the completing the square method. Okay, but the differentiation method for solving quadratic equation, most of us are not familiar with it. The depressed or symmetric equation method for solving quadratic equation, most of us are not familiar with it. The matrix, or the circular matrix method, most of us are also not familiar with it. Then the undetermined parameter method, which most of us are also not familiar with it. I also encourage you to follow me, like and share this presentation, so that as we go along in this series, you stand to learn more of all these other methods which you are not familiar with. Thank you. I see you in my next episode.